Hi guys, let's start talking about multiplying fractions. So on the previous page, this is page 182 in your workbook. On page 181, it's the chapter opener, and they talk about making multiple versions of a recipe where there are things like fractions. I'm not sure how many of you bake, but if you do, you know that sometimes it calls for a third of a cup of milk or half a teaspoon of salt or something where you would need to multiply those. So what we're going to talk about today is how to do that. Again, multiplication is the same as repeated addition. So you could always just keep adding the fraction over again, but we'll take a look at how to multiply them. So the first example that we're going to look at is for a recipe for rice. So a rice pilaf recipe calls for 1/8 of a cup per person. May is helping her father make enough rice for 5 people. How many cups of rice will she need? And so we have this diagram here, which shows that this is what 1/8 of a cup looks like. Again, if you have your measuring cup, it's probably going to look something tiny like this compared to a nice big cup measurement like this. But it takes 8 of these to fill these up. That's what it means to be 1/8 of a cup. All right, so if this is the 1 cup, and I were to break that up into 8 equal parts, it might look like this. And that's what they're representing here when they draw that picture for us. So for the first person, we need 1/8. For the second person, we need 1/8. For the third person, we need 1/8. For the fourth person, and for the fifth person, we all need 1/8. And so all together, that's 1, 2, 3, 4, 5 eighths. And you can see that the measuring cup, the whole cup measuring cup, would still not be full because we could still fit 3 more eighths. But what we have here is we've made 5 eighths. All right, now, again, we could do that by adding 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. That would be the old way to do it. And so we would keep the denominators the same because we're adding the same unit, but then we would add all the numerators, 1, 2, 3, 4, 5, and we would get 5 eighths. Now, from a multiplication perspective, what we're doing is we're taking 5 times 1/8. And what we're going to do is we're going to think of this 5 as 5 over 1. I guess we could think of that. And just talk about that as being a whole number. Remember those fraction circles we looked at where there was one where it was not even cut at all. That's what that would look like. 5 whole things as 5 of those that are not cut into any other than just that one piece. So now we're going to take the 5 of the 1/8. And what we're going to do is we're going to multiply that 5 times the 1 because we had 5 of the cup 1/8. So 5 times 1 over the 8th cup, and we'll get 5 eighths. I'm not sure that you can even see that in there. All right, 5 times 1/8 is 5 eighths. Okay, let's look at another example. I think you're going to find that multiplication is a lot easier than addition. Significantly easier than addition because you don't need to find common denominators when we start doing these more. Okay, so here's the next question. How many 1/5 are in 4/5? So we draw our rectangle, we cut it into fifths by drawing 4 lines that are equally spaced apart from the ends, and then color in 4, that gives us the 4/5, and it says how many fifths are in 4/5? Well, there would be 1, 2, 3, 4 fifths and 4/5. All right, so it's asking 1, 2, 3, 4. If we have 4/5, that would be 4/5, or 4/5 would be broken into 4 1/5 pieces. And then we're showing here, when we do this, 4/5 is the same as 4 times 1/5. All right, that we would take 4 1/5 pieces to get 4/5. All right, and again, the way they did that in the previous problem was 4 times 1/5. They wrote that as 4 times 1 over 5 and got 4/5. And again, I like to put a 1 there because sometimes people wonder what happens to that bottom part. Really, it's like us doing 5 times 1, and nothing changes about that. Okay. Here's the question that May is asking. How many 1/6 are in 5/6? All right, so think about that for a second. Look at the picture. Hopefully you can figure that out. All right, if we have 5/6, again, we take our whole, we break it into 6 equal parts, and then we shade 5 of them to indicate that we have 5/6, right? And then it says how many 1/6 pieces are in there, right? So 1, 2, 3, 4, 5, right? So 5/6 is made up of 5 1/6 pieces, right? And so let's go and show that down there. 5/6 equals 1/6 and 1/6 and 1/6 and 1/6 and 1/6. Or you could say 5/6 is 5 sets of 1/6. Okay, next one. Here we're going to use fraction circles, and it's saying, suppose we had 3 sets of 1/4. All right, so again, remember those fraction circles that we used in class that time. If we had 1/4 here, and 1/4 here, and 1/4 here, again, that means it's one part of a circle that's cut into 4 equal pieces. So we have 3 circles like that. We get to take one from here, one from here, one from here. If we were to group them all together into their own circle, we would get 3/4, right? So 3 times 1/4, again, we multiply this, right? Again, I'm going to put it over 1 because I want you to see that we do top times top and then the bottom times the bottom. So here, 3 times 1 over 4, that 3 times 1 gives us 3/4. And we can see that in the picture, that when we take those 3 1/4 pieces and we put them together, we get 3/4. All right, next one. 4 times 1/2. So here we see that. We have 4 1/2 pieces, and we're going to stick them together. So again, we take these two and put them together to make a whole. Take these two and put them together to make a whole. But here's what it's going to look like up here. We're going to take the 4, I'm going to put this over 1 so that you see that it's numerator times numerator. So it's 4 times 1 over 1 times 2 gives us the 2. 4 times 1 is 4. All right, now what we have here, I don't know if you can even see this on the camera. What we have right here is 4 over 2. That is an improper fraction, which means that we need to change it to a mixed number. All right, in this case, we're not going to even need to change it into a mixed number. It's going to become a whole number, because when we take and make groups of 2, again, that's what we're trying to do. How many groups of 2 can we make out of 4? We make 2 exactly. All right, and we can see that in the picture, that there are 2 groups of 2 whole circles that we make. Okay, next page. This is page 184. All right, so turn your page to 184. Find the product of 5 and 1/3. So again, that word product, we've talked about before. Product means an answer to a multiplication problem. An answer to a multiplication problem. And again, that's important because they're gonna say stuff like that to us: product, sum, difference, quotient, and they're gonna expect that you know what that word means and that you know it means to multiply. All right, so if it said find the sum of 1/5 of 5 and 1/3, we would have to add. If it said find the difference, we would have to subtract. Product means multiply. Quotient means we would have to find 5 divided by 1/3. All right, so it's telling us to multiply 5 and 1/3. And again, they're just doing that because there are a lot of different ways that you can see it, and they want you to get comfortable with all of them. So 5 times 1/3, here they're using a number line, all right? Again, lots of different ways to represent 5 times 1/3. So here, it's like if you could walk down the street and each time you took a step, it was 1/3 of a yard, all right? So then, and you took 5 steps. So here's 1, here's 2, here's 3, here's 4, and here's 5, and it wants to know how far have you walked. All right, so 5 steps at 1/3 each. Again, I'm going to write this over 1 so that you see we're multiplying the numerators. 5 times 1, and then the 3, because that's going to be 3 times 1 in the denominator. 5 times 1, let me write that down here, is going to be 5 and 3. All right, again, improper fraction right here. So we need to change that to a mixed number. Now we can easily look up here and see what that is. that when we go 5/3, 3 of the thirds make 1, and then we have 2/3 left. So we could say it's 1 2/3. Or we could say, well, with 5/3, I want to find out how many groups of 3 I can get out of 5. In other words, I'm going to do 5 divided by 3. When I do 5 divided by 3, I get 1. All right, I can only make one group of 3 out of that, and then I get 2 left over, and that 2 says I have 2 of our thirds pieces left over. After I've made a group of 3, I have 2 pieces left over. What were those pieces? They're called thirds. Okay, so then let's do a couple of these, and then I'm going to ask you to turn off the turn off the video and come back and check your answers. So let's just do the first 2 together, A and B, and then you do the rest and come back and check. Then we'll do problem 5. All right, so again, 5 times 1/7. I'm going to write it over 1 so that we see 5 times 1 is 5, and 1 times 7 is 7. So you should get 5/7 there. All right, again, 3 is the same as 3 over 1. So I'm going to do numerator times numerator. 3 times 1 is 3, and 1 times 5 is 5. All right, now go ahead and pause. I want you to do these 6. Probably don't write them in your book. Just do them on a piece of scrap paper and then come back and check to see what to see whether your answer is correct. Don't forget that if you get a fraction that can be reduced or an improper fraction, that you fix it so that either you reduce it or change it into a mixed number. Okay, I'll see you in a minute. Okay, this should be 6 times 1 is 6 over 8 times 1 is 8. These are both even, and so they can reduce. This ends up being 6 divided by 2 is 3. 8 divided by 2 is 4, so this should be 3/4. For part D, this is 4 over 1, so 4 times 1 is 4. 1 times 4 is 4. 4 over 4 is the same as 1. There is one group of 4 in 4. All right, 9 times 1/3. 9 times 1 is 9. 1 times 3 is 3. And we end up with an improper fraction. And then we're asking how many groups of 3 are there in 9? There are exactly 3 groups, no leftovers. All right, letter F, you should have done 6 times 1 is 6. 1 times 12 is 12. And then 6 and 12 are both even, but even more than that, 6 and 12 are both divisible by 6. Right, so 6 divided by 6 is 1, 12 divided by 6 is 2, so this would be 1/2. And letter G, 1 times 10 is 10, 1 times 4 is 4. They're both even, so we could reduce, or we could do mixed number first. I'm going to do mixed number first and then reduce once. So how many groups of 4 are there in 10? Well, there would be 2 groups, right? Because 4 and 4 is 8. There are still 2 left over after we do that. So it's 2 and 2/4. 2/4 is something that can be reduced because 2 and 4 are both even. So this becomes 2 and 1/2. And then the last part, 9 times 1 is 9. 1 times 6 is 6. Improper, and something we can reduce. So let's see, improper, let's fix that. There is one group of 6 in 9, and there are 3 left over. And then 3/6 can be reduced, and that becomes 1/2. Okay, hopefully you're finding those pretty easy, because again, unlike adding, you do not need to find common denominators. You're just multiplying across. Okay, let's take a look at this. A red ribbon is 1/3 of a meter long. A blue ribbon is 3 times as long as the red ribbon. Right? So again, remember when we were drawing our bar graphs here a while ago, that we would say that this was the red ribbon. Again, they've drawn it for you, but if they didn't, we would say, oh, we know that the blue ribbon is longer because it says it is 3 times as long as the red ribbon. So that's why they've drawn it this way. It's 3 times. So if this is 1/3 of a meter long, this has to be 1/3. This section right here has to be 1/3, and this section has to be 1/3. All right, so let's go back. We've got the diagram all set up and it says, what is the total combined length of the two ribbons in meters? So let's find out, first of all, how long the blue ribbon is. All right, so that's asking us, actually, we don't even need to do that separately because it's asking us to find out the total of all four of these. They're all identical lengths. So what we could do is we could do 4 times 1/3. We have 4 pieces that are 1/3 of a meter in length. All right, so how do we do that? Well, it's the same as we just did. We do 4 times 1 is 4, 1 times 3 is 3. Improper, so we're going to change it to a mixed number. This is saying, this is asking us how many groups of 3 can we make out of 4 pieces. We can make 1 whole meter. That's this part right here. Coincidentally, that piece made up 1 whole meter. And then we have 1 of those pieces left, and it's called 1/3. So 1 and 1/3 all together. We actually didn't even need to write it as the 4 times 1/3 because that nice visual they gave us, this made up 1 meter, and then we had 1 extra. Okay, hope that was helpful to you, and I will see you later.